Hi guys, once again, this is another kind of an informational video about vacuum tubes and some common, well, or depending on how you think about it, not so common failures. This is a peculiar case that I have a tube. Philips Mini Watt UY85, it's kind of an odd numbering type, isn't it? Well, this tube clearly does not look quite right. It's got ugly, corroded, nasty pins, like some kindergartners shoved them up their nose. And those old 80-year-old kindergartner boogers just kind of crusted up on the pins here. That's not good for continuity. Well, so the filament, obviously, it was tested fine for continuity, but we got bigger problems here. Like, I don't know, there's no vacuum. So when you see a tube that looks like this, where there's just no getter left, it's all white, it went to air. It's pretty easy to see how it did. You see cracks around the pins here. Now, a common cause of failure for vacuum tubes, one of the most common ones, is actually not the tube going bad. It's going to air because the pins are bent, and then that causes the glass to eventually crack, form micro cracks, and heating and cooling over and over again, as we know with a lot of materials, does not go very well. And this is probably what happened to this tube. This was part of that 100 tube lot I got, and of course they were never tested or examined, but that was part of the conditions. These were really cheap, like 50 cents a piece. So this is just kind of interesting informational thing to look at, though, to see just what happens to a vacuum tube when they fail in a particularly catastrophic way. It's not like there's not glass falling off of it. It's just cracked. And here's the horizontal tube, which was from the Ford Philco that I've been working on. This was the first thing I had to replace out of the TV. It's a horizontal output tube, a 6KD6. And again, for horizontal tubes, they've failed. It's pretty obvious usually when they fail. In this case, this one arced and had purple plasma. Like, I think it literally was plasma. It was just going to the oxides on this side because they became conductive, and it was basically, and if it kept going, it would have basically burned a hole, melted a hole through the glass, and then that would have been very terrifying. So obviously this was bad too. I'm actually going to have to go through some other tubes. I'd forgot. You can also check tubes for shorts with a multimeter as well. I'd almost forgotten about that. You can do more than just a filament test. And if you have a shorted tube, well, shorts are bad for any circuit, solid state or tube. You do not want shorts. So that is another just informational video. Thanks.